Welcome to Random 101 Coding, presented by the Carleton Student Science Society. I'll be your host for this video. My name is Jacob Schrader. I'm currently a third-year computer science student here at Carleton, and my goal for this video is to teach you the absolute basics of programming so you can get on your way. For this tutorial, we will be using the online interpreter of online-python.com, so please navigate to that in another tab now. And we will also be hosting this final project, so the goal of this tutorial and the program that we're actually going to write on my personal GitHub, github.com/JacobJSchrader. So let's get into it. The goal of this tutorial is to create a Carleton GPA calculator. I've always found that the way Carleton calculates its GPAs is kind of difficult, and if you're doing it by hand, it requires a lot of manual calculator work, which is never fun, and it's very easy to lose your place. Computers are a lot better at knowing where they are. So we're going to be converting these steps here into code that we can run on the online interpreter that I've shown you the link for previously. A lot of computer science is based on taking a list of instructions and turning it into code so that a computer can read it and process it. And that will be our goal for that here. So you can see we have a list of steps, listing all the courses you've attempted, the corresponding credit values, 0.5 or 1.0 credits, and your final grades. So we're going to need, in our program, some way to list all of the credits that we've had and all of their associated values and final grades. Then step 2, we're going to need to record the grade points earned for each course and add them up. So we're going to have to make a part of our program that is able to add up all of those grades that we've received. And keeping in mind that the 0.5 credit courses are worth half the point values. So we're going to need some mechanism to half them if they are a 0.5 credit course. Then step 3 is add up all the number of credits you've taken, which is a bit of step 2, and it'll get a little murky when we start to code it, but you'll see when we get there. And finally, divide the total number of grade points by the total number of credits. So we'll need to take that total that we have and find the total number of credits that we have as well, and put that into our program. So let's start on some prerequisite knowledge that we might need to get into the coding this. So first we're going to start by learning some primitive data types. The word primitive data type kind of sounds scary, but they're fairly intuitive, so I hope you can pick them up pretty quickly. We'll start with strings. A string is a variable storing text. So you can see here we have x equals hello world, which is a string containing hello space world. So you can see it can be a word or a phrase. It doesn't have to just be one word not separated by spaces. You can put an entire sentence or multiple paragraphs in one. It really doesn't matter. And they are characterized by double quotes. So you can see the double quotes turn this word here into a string, so Python can interpret it properly. Here we have an input prompt, which takes the word written in here as a prompt for input and prints it to the console, and then asks the user to type some sort of word in. And then once you hit enter, it'll sort of save the word to that variable y, whatever you typed in. And then we have print x and print y, which just prints whatever's stored in those variables to the console. So here I've made a fake console where I printed out the first input line that gets ran. Imagine I typed in dog, and then here I've typed in dog. And we do print x, which will print hello world, and then print y, which will print dog, which is the variable y that got stored with the input. Next we'll be learning about integers. An integer is a variable storing a number. Only whole numbers and no decimals. So you can see here we have x equals 5 and y equals 10. For an integer you couldn't use, say, x equals 2.5 as it only works with whole numbers. They're just like math class. If you've gone over numbers, they're pretty much just whole numbers without any decimal points. All the basic operations work with them, so you can see a is x plus y, b is y minus x, c is y over x, and d is x times y. So here we have a couple print statements, so we can see what it would be if we were to run it as code. We have the print x, which prints the 5, a, which is x plus 5, prints 15, b, y minus x, prints 5, c, y over x, prints 2, and x times y, which is d, will print 50. Next up we have Boolean values. A Boolean value is a variable assigned either a true or a false value. So here we have x is equal to true and y is equal to false. Booleans is where you'll see the ones and zeros that are always associated with computer science. A 0 is false and a 1 is true. There is only true and false as well. There's no in-between, and there's no gray areas in computer science. It's either one thing or it's not. Here we have a bit of an example. As stated earlier, x is equal to true, y is equal to false. If x is equal to true, then we print true, and if x is equal to anything else, which is called by this else statement, then we will print false. And as x is equal to true, we've printed out true. So I know you were worried, how are we going to represent decimal values in our code, because the integer only works with whole numbers. Luckily, we have floats for decimals. A float is just a variable with a decimal value. They are different from integers, that's why they have different names, and they're different for reasons that I'm not going to go into in this video. You can look it up on your own time, but it's fairly complicated, and will make this video much too long if I went into explaining it. If you need a decimal, you need a float. They can interact with integers, as we'll see when we get to coding up our project, but they are different, so just have that idea in your head. Here we can see x is equal to 2.5, y is equal to 0.7. All the arithmetic operations work. We can do plus, minus, times. I don't have divide here, but you can divide fine. And to show what it would look like in a program, we have print A, print B, and print C, which will print the products of all of these various operations, as you can see. You can check my math if you'd like to. I showed these off a bit in the Boolean example, but they are very important, so they deserve their own slide as well. These are if-else statements. They are called conditional statements. So the if needs a condition to be valid, and if the condition inside of the if block is met, then that segment runs. Else is a catch-all, so if an if does not run and nothing is found that satisfies the condition inside of it, the else will run instead. So here we have an example of an else being a catch-all. Since x is equal to 5, if x is equal to 4, then we print x is 4. And if x is not equal to 4, then we print x is 5. So here, since x is not equal to 4, we go to the else, and then we print x is 5, which is in our console down here. Next up, we have for loops. For loops are called counter-controlled loops, as the amount of loops is determined by a range, or a pre-selected amount of items. They're very useful when we know the amount of loops we want. So here we have fruits equals apples, banana, and cherry. So for x in fruits, print x. So that will print the 3 items in this array: apple, banana, and cherry. Now we have one that works with a range. So for num in range 1 to 5, print num. So this range is x inclusive on the first one, but exclusive on the last one. So we will print 1, but we won't print 5. We will only print to 4, which is shown here: 1, 2, 3, and 4. There's also another type of loop called a while loop. A while loop, otherwise known as a sentinel-controlled loop, is like a for loop mixed with an if statement. It's a loop that will continue to run until a condition is met, and it's very useful when we don't know the amount of repetitions we might want. So here we have an example of a while loop. Num equals 0, while num is equal to 5. Num will be added 2 by 1 and then printed out. So here it starts at 0, gets plus 1 to 1, and then again to 2, again to 3, and again to 4. At 4, it again runs because at the end of here it is 4, so it's not equal to 5, and then it'll be added 2 by 1, printed to 5, and then it'll stop running because num is equal to 5, and the condition is while num is not equal to 5. And last on our prerequisite knowledge is an array. An array is a table of other variables. It can be added to or removed from, and it's important to remember that it starts counting at 0. So here we have x equals dog and cat, which is an array containing the strings dog and cat. And then x will dot append, which is adding snake to the end of the array. So here we print x, which will print the entire array, which contains dog, cat, and snake. And then here we print x at 2 instead of x at 3, because again, arrays start counting at 0. So the 0th element is dog, this first element is cat, and the second element is snake, which is actually the third element. A little confusing, but you'll get the hang of it. And then here we do x.pop 0, which will pop the 0th element, so the first element from our array, which is dog. And then we have a print x, which will print cat and snake as we've removed dog from the array. So now if you haven't already, please navigate to onlinepython.com. When you first get here, there's going to be some code that they've pre-written up in this corner here. Just delete that out of the file, we don't need it. So what are we going to do to start? We'll probably want some sort of greeting. So for that, we'll just print a nice little string to the console. I don't know, we can just say, hi, Carleton GPA calculator. Then next up, we need to have some sort of method to get all of the grades. And since we don't know how many grades we'll want, and we'll need a loop to calculate the grades, we should use exactly a while loop. So do while, but we need some sort of condition for a while loop. So let's call a variable done, and we will set it to false, because obviously when we set the variable, we don't want the loop to be done. So while done is not true, do something. So we'll probably need some sort of input for a grade. So we'll say a grade is equal to input, and we'll set the prompt to just input grade. And we also need to put the weight, so we will do weight equals input. Oops. Input grade. Weight. So this is good, but sadly we don't have anything that is storing these while we loop. So we should probably make a couple of arrays to keep these variables in. So we'll call one grades, and we'll set that equal to an empty array, because there should be no grades when we start. And we'll also keep weights, which again will be an empty array. So now we can append this grade value to the grades array. So grades.append grade. I don't like what it's doing there. Grades, this is going to be weights. Do the same thing for it. Weights.append weight. So now this is nice, but we have no way of getting out of this prompt while we're in this while loop. Ha. So we're going to need some sort of prompt to end off this loop. So we'll call that done prompt, and we'll set it to input to get some sort of word. Are you finished? Just say that. And then we'll say the user's supposed to write yes if they're done. So if done prompt is equal to yes, then done equals true, and that will end the loop. So here we can just test this quickly. We're going to put a couple of print statements. We'll remove these after, but for the time being, we should probably print to make sure that we get all of our grades. Print grades. Print grades and weights. So we'll run the code. So input a grade. We got a 10.0. Input a weight. We'll do 1. And are we finished? We'll say yes. We just need the 1 to test. So there, we have 10.0 and 1. So one problem that we might see is these grades are being set as strings in our arrays, which we do not want. So we can make them into floats by surrounding them with this float keyword, which will convert it into a float if it is float convertible. So just make sure that you only type in a decimal value or some sort of number, or else it will break the code if you say like dog instead of a number here, because it cannot convert dog into some sort of decimal value. So here we can remove our prints as we've done debugging stuff and testing it out, and we can see that our loop works and finishes. So now remember, we need a total for all of these grades. So we'll set total to equal 0. Now, we know how many grades we want, and we want to make sure that we add all of them up together. So since we know how many grades, we can use a for loop. So for, we'll call it number, in some range of 0, starting at the base array at 0, and then all the way to len. And since both of these are the same length, we can use either array. So we'll use the length of the grades array to make sure that we iterate for that many loops. So there we have that. And then normally you'd think now we just add all the grades, but remember we have that condition where if it's a half point, then that grade's value gets halved. So we need an if statement to catch that. So if the weight at num is equal to 0.5, then total gets added to plus equals grades at 2 divided by 2. Grades at num divided by 2. Grades at 2 will always use the second grade, but grades at num, since that is our counter, will go for whatever grade that we're currently at. And then an else, so catch if it's equal to 1, total will just be equal to grades at num. Will just be added to by grades at num. So there, we have a loop to calculate all that we need for the values of the weights and the grades. And the last thing that we need to do is get the average. So average, screwed up there, equals total, which we've now collected, divided by the len, so the amount of elements we have, so len grades. So now we're pretty much finished. Please note that the weight variable here needs an s on the end, so we use the array instead of this weight, which is just set to an individual number. But aside from that, we are done and we're ready to run our code. So we'll try it out with a couple of grades. So we'll put a 10.5 in for a full year course. We're not done. This can be anything to not be done as long as it's not a yes, then this won't run and the done won't be equal to true, breaking the loop. So we can input another grade, 11.5. We're doing really well this year in a half-year course. We are not done yet. Still want to put in like 2-ish more grades. I didn't do very well in one course, and that was only a 5.5 in a full year course, sadly. So that's going to hurt the average a bit, but I'm not finished yet. I also got an A+, did really well in a course, and that was another full year course, so it helped us out a lot. Now we'll say done. Please note these aren't my actual grades, these are just tests. And we're gonna say yes, we are finished. And we'll see that our average here, it gets calculated in this loop and will be printed to the terminal here. Our average is 8.4375, which I'm sure is correct. Thanks for watching this video. I hope that you enjoyed it, and I hope that you've picked up some basic understanding of coding over the course of it. With this video, you should be able to automate other simple tasks in your life, and I hope that you do so, because it's very nice to learn, and as you've seen, it's not very difficult to turn a couple of steps into code. Good luck with any future endeavors in programming, and I wish you all the best. Goodbye.